Hi guys, I'm here today with a video about scatter plots. The goal of today's video is to help you find the slope and y-intercept, is to help you to write equations of a line, and to help you to graph by hand and by calculator. So let's get started. Okay, so what I suggest that you do is take out a piece of paper and a calculator and do this problem along with me. So it says a history teacher asked her students how many hours of sleep they had the night before a test. The data below shows the number of hours the student slept and the score on the exam. Plot the data on the scatter plot. So we're saying that their test score depends on how many hours they sleep. So this is the dependent variable. So it's going to be the y. And this is the independent variable, which is the x. So what we're going to do here is we're going to plot the hours on the x-axis and the test scores on the y-axis, and this is an ordered pair. So one student that slept 8 hours got an 83 on the test. Another student that got 7 hours of sleep got an 86 on the test. Okay, and you're going to do that for all of the points. So let me speed it up a little. 774, 888. I think I did that one wrong. Yeah, that should be more like that. And so on. So just to save time, I've already done it on the next page. What I'd like you to also do right now is go ahead and put these data points in your calculator. So you're going to go to Stat, Edit, and you see that I've already done that. I've put all the hours in list 1 and all of the test scores in list 2. So go ahead and push pause, enter that data, and we'll meet back in a few seconds. Okay. So your scatter plot is going to look like this. It's got a positive direction, so we're going to say it's positive association. We don't know how strong it is yet, and we don't know the form of it yet, but we can definitely see that it's moving up. So sleep is important. So let's write an equation to this line. If I wanted to write an equation to that line, we would need to find the slope, the y-intercept, and then the equation of the line. And if you look at it, you have all these different variables that you need to solve for, and your calculator can do all of that. So let me show you now how to do that on your calculator. So using your calculator from the home screen, let's do correlation first. So we're going to push Stat, Calc, and then number 8. And if you have a calculator like me that's older, you're going to push list 1, comma, list 2. If you have a brand new calculator, I think it would prompt you like what's the X list, what's the Y list, and then it says calculate. Go ahead and do that, and then push enter, and we all should get this. So you'll see right here that this is the correlation. It's a positive 0.88. We already knew it was going to be positive because it was a positive slope, so this reaffirms what we thought before. And it's also a strong correlation, 88. Some of you might say moderate, but I think this has a tendency to be strong. So write that down on your piece of paper. R equals, I'm going to write that down, R equals 0.883. All right, now let's get X bar, Y bar, and all those standard deviations. So to do that, you're going to push Stat, Calc, and number 2, because now we're dealing with 2 variables. And again, you're going to tell it what list you want it to read. So I want it to read list 1, comma, list 2. Newer calculators will say X list, Y list. And here are all your data points that you need. So what you're going to need for this problem is X bar, which is 6.8, standard deviation of X, which is 1.475, Y bar, which is 79, and standard deviation of Y, which is 10.656. So hopefully you're getting the same numbers as me. If not, that means you entered in a number wrong, so go back and check your work. All right, so now let's write the equation of this line. So let's do some math. Okay, so here are the equations for, this is what we should have got. So I just moved over the equations for slope, so let me just rewrite them really quick. Slope is the correlation times the standard deviation of y over the standard deviation of x. So we know that the correlation in this problem is 883. The standard deviation of y is 10.656. And the standard deviation of x is 1.475. And to save time, I've already worked this out, and it comes out to 6.379. So as you're watching the video, just push pause and do these problems out and see if you're getting the same thing I am. Now, y-intercept is a equals y bar minus b x bar. So that's going to be 79 minus 6.379 times 6.8. So there's y bar minus b x bar. And so our y-intercept comes out to 35.623. Okay, so now we have a slope, and now we have a y-intercept. Sorry, I forgot to put my phone on silent. And now we're going to write the least squares regression line. So the line is going to be the predicted y equals the intercept, 35.623, plus the slope, 6.379, times the x. So what you've created here is a function where you can put in how many hours of sleep that you had and predict your test score. So this function can predict test scores. So to make that even more clear, let's write it in terms of the context of the problem. So the predicted test scores is 35.623, plus 6.379 hours. So if your mom says you only got 7 hours of sleep, you could say, well, with 7 hours of sleep, I should get this test score. So let's figure that out right now. What test score do you suspect you should have on your history exam if you slept 7 hours? So we're going to predict someone's test score using this function we created based on sleeping 7 hours. So our test score is going to be 35.623 plus 6.379, and we're going to plug in 7 because that's how many hours we slept. And you're going to do the algebra, and you're going to get 80.276. Not bad. Okay, that's a good test score. So that's how you predict test scores. Now, what if you thought, okay, I really want to do well on this test, so I'm going to sleep 24 hours. Well, if you look at the domain, the most anybody is sleeping is about 9 hours. So if somebody said, oh, I want to do better on this test, so I'm going to sleep more hours, you can explain to them the concept of extrapolation. That probably won't get you a better test score. Hold on, let me turn off my phone. That won't get you a better test score because we shouldn't really make predictions outside the domain. That's called extrapolation. Okay, so let's say we wanted to graph this line onto the scatter plot. So to graph that line onto the scatter plot, we need some points because we can't really use rise over run here because the x-axis or the y-axis is kind of cut off. So before we continue, let's make sure you understand what this equation means. Okay, this is the slope. And for every hour I sleep, I expect my test score to go up by 6.379. So that's how you interpret your slope. For every extra hour I sleep, I expect my test score to go up 6.379 points. And what this number means, the y-intercept, it means that if I don't sleep at all, I get 0 hours of sleep, I should get a 35 on the test, which is horrible, so get some sleep. But in theory, if you slept 0 hours, you're going to get 35 on the test. All right, so let's graph this equation now that we understand what the equation means. So you're going to take the 2 points, and I always just pick the min and the max. So if I found that the minimum x was 4 hours, then somebody slept 4 hours, I'm going to go ahead and plug it in. Oops. And for 4 hours, I should get a test score of 61.139. So I'm going to graph that ordered pair. And I'm also going to do the max. And you could have done any 2 points. I just chose the min and the max because I think it's easier to do it that way. But picked any 2 points. And when I calculate the max of 9 hours, I should get a 93. Ooh, that's nice. You should get a 93. So that is 9, 93. Okay, we're going to go over here and we're going to plot those and connect the dots. So 461 and 993. Let's see if I can draw a straight line. And there's your equation of the least squares regression line. Okay, let's say you wanted to do this on your calculator. All right, we already have our data in our calculator. And so what we're going to do here now is we're going to turn on the scatter plot. So we're going to go to second y equals, and we want to go to plot 1. And I have my histogram on from like an old homework assignment, so I need to make sure that the graph is on and the scatter plot is on. And then I have to direct it to what list to use. So I'm going to tell it to use list 1 and list 2. So take a second and make sure your screen matches my screen. And when you're ready, you're going to push zoom 9. And so that definitely matches what we have here. So now we want to, just for visual practice, we want to see what does it look like if I have the equation right on top of here. Well, one easy way to do that is just to go to y equals and type in your equation. So if you type in your equation, it was 35.623 plus 6.379 times x. Right here's where you can find the x. So you're going to push x. So that's the equation of the line that we calculated. You're going to push zoom 9, and it should go right through, and it looks very similar to what we got. All right, and some of the cool features on here is you can push trace. And right now it's tracing my ordered pairs. If I use the right and left arrow key, it's popping through all the observations. And if you use the down arrow key or the up arrow key, it's going to, and use left or right after that, it's going to go through the line. You can see it moving up and down the line. And then you can type in any observation you want. So we know, we predicted in the last example 7 hours. So let's just push 7 and then enter. And that's exactly what we got on the last screen. 7 should get you an 80.27 on the test. Okay, so that was a quick explanation on how to graph and calculate least squares regression lines. I hope that helped.